So now that we know what a random variable is, let's talk about transforming random variables. And to do this, we need to think back to Unit 1 when we were transforming data sets. Now, if I add or subtract by a constant, remember that this will change the center, but not the spread. And I always think of SpongeBob when Patrick was like, let's take Bikini Bottom and push it over there. You're not changing the size of this distribution, you're just changing its location. So adding or subtracting will change the center. Now, if you multiply by a constant, this changes both the center and the spread. Meaning that now the shape and the location are, not the shape, but the size and the location are going to change. And this goes back to rigid motions. Translations do not alter the size, they change its location, but a dilation alters the size and can possibly change its location. So that's just our quick brief review there from Unit 1. So let's take a look at what this might actually look like. Now we're going to go talk to our good friend Pete here. And Pete's Jeep Tours offers a popular half-day trip in a tourist area. There must be at least 2 passengers for the trip to run, and the vehicle will hold up for 6 passengers. Define X as the number of passengers on a randomly selected day, and Pete charges $150 per passenger. And also the standard deviation of X is 1.09. X has the following distribution. Probability that there will be 2 customers is 0.15, and the probability that there will be 4 is 0.35. So give me one quick moment. Sorry about that, y'all. Had a few statisticians pop in and get excited for the semester, but I think by the time you see this, we already would have been putting up with each other for 3 months. So it's all good. Let's get back to Pete. Now, Pete's Jeep Tours, we already talked about that. Let's find the mean or the expectation of the distribution. And remember, we can do so by applying the following formula. We're going to take the sum of each observation and multiply it by its probability. So I would take 2 times 0.15 plus 3 times 0.25, and I would repeat this process for all of the values here. And when I compute this, my mu of x, or my expectation, comes out to about 3.75. So if I were to interpret that, it would sound something like, in the long run average, we'd expect the number of customers or the number of passengers to be about 3.75 passengers. So that's pretty reasonable given that it varies between 2 and 6. Now let's interpret the standard deviation here at 1.09. So here we've got that in the long run average, and this is standard deviation. So we're talking about the variability of the distribution from the mean. So in the long run average, the number of passengers varies from the mean by about 1.09 people or passengers. So the key components there are what the value is, the element of variation, the fact that this is a long run average collected after many trials, and what are your units? You know, elephants, cookies, sticks of dynamite. Here, not as exciting, just the number of passengers. So there is that for you. Now, using our distribution here, let's find the probability that the number of passengers is less than the mean number of passengers. So this has become a more popular question on the AP exam. So I want that the number of passengers is less than the mean, and the mean was 3.75. So looking at my distribution, I'm looking at what x values are less than 3.75, and you guessed it, that would either be 2 passengers or 3 passengers. So the probability of 2 passengers is 0.15, and the probability of 3 passengers is 0.25, meaning that I'm going to have about a 40% chance that the number of passengers is less than the mean number of passengers. So again, with random variables there, you can see that it could apply a rule of probability, or you could be asked to find the mean or the standard deviation. Now, that was the initial, but let's see here. We now have a new random variable called C, and this describes the amount Pete collects on a randomly selected day. It cost Pete $100 per trip to buy permits, gas, and a ferry pass. Now, we need to model the distribution for C. There's a lot going on there, but C is the amount that he collects. And we were told that per passenger, they are expected to pay about $150, meaning that for 2 passengers, I would collect $300. For 3, $450. For 4, $600, and then you can fill in the rest. So this would be the amount right? The passengers, actually this would be the money collected. And a same thing here, find the mean and standard deviation. So let's actually define what C is mathematically. C was equal to 150 times X. So now we're seeing there's multiplication here. So maybe I don't understand that from the get-go. So let me just find the expectation. And again, I do so by taking each observation and multiplying it by its probability. So I'll do 300 times 0.15. And I'm going to add it all the way up to 900 and 0.05. And if I were to do this time and time again, my mean of C, mu of C, would be about $562.50. And I'm actually going to change this here because I said the expectation of X, but this is no longer X, this is C. So this is the mu, or the expectation of C. Now let's check out sigma C. Well, 150 times X, let's think about this. 150 times 3.75 is actually 562.5. And that's because multiplication changes the center and the spread of the distribution. Meaning that if I am multiplying, I should also change the standard deviation by that original amount. So I'm going to take 150 times the original standard deviation of 1.09. And that's going to tell me that my observations will vary from the mean by about $163.50. So note that the same thing happened here for mu of C. It was just 150 times mu of X. So we're noticing some rules here. So let's check again. Now, after the cost, I have to pay $100 for the materials. So now V is the profit that Pete makes on a randomly selected day. Now, profit is cost minus your profit minus cost, revenue minus something. I don't know. There's a reason I don't teach finance. Now, V is going to equal C minus $100. And C was 150X minus $100. So here I had 300, but I have to pay out 100, so that'll be 200. And I'm actually just going to shift each of my observations down by 100 units. So notice that from C to V, they've all shifted down a certain amount. Well, you can use either one here because you can either find the original or you can just take it from C. So we're going to just take it from C here. And if I want mu of V, well, that's just going to be the C of that previous random variable minus 100, meaning that 562.5 minus 100, that's going to give me that my long run average profit is going to be about $462.50. Now thinking about the subtraction, right? I'm just moving the location. I'm not changing the dimension of that original distribution. So the standard deviation of V is just going to be the original standard deviation of C, which is still going to be that $163.50. Now, notice that there's a lot of patterns here. When I add or subtract, I change the center, but when I multiply, I change both the center and the spread. So there's actually a few rules here for random variables. Now, I forgot to add the subtraction sign, so just go ahead and add those in for you. But looking at these rules, they're actually not on the AP exam, so you do have to memorize these. But it's something that we haven't talked about. For example, addition or subtraction only changes the center, and multiplication also changes the center. Now, if you do both, it would change by that scale factor and then the shift of whether you're adding or subtracting. Thankfully for this variance and the standard deviation, not much changes. So when you add or subtract, it doesn't change the spread of the distribution. But when you multiply, it does change the dimensions of that distribution. You're changing it by a constant. So we do have these rules here. And notice that it's the same once you're multiplying, because only multiplication changes it, not the addition. So these rules you just have to memorize. More specifically, just the mean and the standard deviation will get you through it. And that's just because variance is kind of like our long lost cousin. Like sometimes it's fun to hang out with, but we don't really feel pressure to get to know them. And so for us in AP Stats, we'll just focus on the mean and the standard deviation. So we have the following now. There's some examples for you here. A large auto ship dealer. So doing the same thing again, where you are looking for the, you're just modeling the situations and finding the new information. And then here is another one where you will have to find the distribution parameters and then find the transformed parameters. So what I need you to do now for me is go ahead and pause the video. Try these examples out honestly. Should take about 10 to 15 minutes. Go ahead and try them for yourself, and then we'll come back together and review them. So go ahead and pause the video now and try your best. Alrighty, so hopefully not too scary. So here in the long run average, the number of cars sold is about 1.1 cars. And in the long run average, the number of cars sold varies from the mean by about 0.943 cars. In the second situation, we found that we receive a $500 bonus per car. So we're going to take Y and we're going to multiply X, the number of cars sold, by $500, giving me my new mean and my new standard deviation. Here, in order to incentivize customers, we need to pay out and get some donuts and coffee. But that's going to cost us $75 of what we're making from the bonuses. So we're going to subtract that each time, so giving me again my new parameters. Here in example 3, we created the following distribution by looking at the amount of money won and the probability that each of those amounts is won. We find our expectation as well as our standard deviation of 10.5 and 6.5. And we looked at W as the total amount won, which is X minus 15. And notice that where this comes from is that X is the amount that you win, but $15 is the amount that you spend. Therefore, if I win $5, I had to pay 15, so I really lost $10. If I win $10, I still had to spend 15, so I lost $5. And if I win $20, I still spent 15, so I actually only won $5. So this function here helps to model that. And when I do that, notice that I have a negative average. This game is probably not great to play in the long run because it says, what this tells me is that in the long run average, I'm going to lose money. And that is just not a guarantee. That's a guarantee in the long run average. So it doesn't sound good that I'm looking forward to losing. So I'm not going to play that game. And we can see that this has a fairly large standard deviation. So the odds are not in our favor here. No Hunger Games. We are not playing this game. Now, one thing I did want to comment on is that if you'll look at my work here, there's typically 5 components. So the first one is the parameter that we're looking for. Is it the mean or the standard deviation? The second component is the transformation being applied, or the formula that you're going to use. The third component is the work shown. The fourth component is a correct answer, and the fifth component is a unit. So that can be cars, that can be dollars, elephants, cookies, sticks, or dynamite, etc. But typically on the AP exam, they're looking for those 3 to 5 things because each year the rubrics change. But moral of the story here, this is how we transform random variables. These are all the rules that you'll need to memorize. Unfortunately, they are not on our AP Stats formula sheet. But again, addition changes the center but not the spread, and multiplication changes both the center and the spread. So if you can remember that key fact, you can kind of finagle your way through. But that's going to conclude our lesson on transforming random variables. And in the next lesson, we're going to talk about what it means to combine random variables. So stay tuned for more.